This is a quick demo showing what you can do with 3DMake using NVDA. So I have the NVDA output piped through so that blind users can tell what's going on in the screen. And we already have 3DMake installed, so I can type 3DM commands and run them in the terminal. I'm just using the basic cmd.exe command prompt here, which seems to work pretty well in my version of Windows with NVDA. So I can create a new 3DMake project by typing 3DM new, and if I hit enter, it will prompt me for a project name.
Choose a project directory name left paren. Press enter for current dir right paren, colon.
So usually you don't want to use the press enter for current directory, but if you've already made the directory and it's empty, you can do this. So I'm going to call my project example. So
C:\users /Troy greater.
That's just the prompt telling me that that's the directory I'm in the command line, and I can change into the example directory by doing cd example.
C:\users /Troy /example greater.
So now I can list the files that are in here that were created as part of the default project template. I can do that by doing dir and then /b. We'll give it a sort of cleaner listing.
3DMake.toml build src C:\users /Troy /example greater.
So 3DMake.toml contains settings for the project, and it tells 3DMake that this directory is a 3DMake project directory. And then build is where outputs are going to go, and source is where the source files for the OpenSCAD models are going to go. We actually have one source file already that's created with a default source, and we can see it if we do dir /b src
main.scad C:\users /Troy /example greater.
So that folder contains a main.scad. Now we can just open that with any text editor, but we do have a convenience function in 3DMake. We can do 3dm edit -model.
S.
And if we open that, it's going to open Notepad.
Main.scad -notepad. Text editor edit multi-line / set up parameters for smooth models by default.
So we've got some just basic variable setup in here and a sphere with a radius of 40 millimeters. It's a fairly large sphere. So if I read all the contents of the file, you can see what the default is going to look like.
/ set up parameters for smooth models by default $fs = 0.1 semi, $va = 1 semi, / your model code here sphere left paren, 40 right paren, semi.
So by setting $fs to 0.1, that's the smallest feature size that it'll create. So you get smoother models, and $fa is 1. So like if we have a cylinder, we'll have 360 faces on that cylinder because it's the angle for the smallest feature. Then we have a sphere with a diameter of 40. So if we switch back to the terminal window,
C:\users /Troy /example greater.
so that's just the prompt here. And if I want to build this, I can just type 3dm build. So this will create an STL file. It's just going to be in the build directory, and I can list it. So if I do dir /b build
main.stl C:\users /Troy /example greater.
main.stl. So another feature we have in 3DMake is that we can use AI to describe the model to you. So this can save you a lot of time versus just printing the model and feeling what it feels like, because for larger models that can take several hours. So you can do this using the 3DM info command, and it will do an exact measurement of the model, sort of a bounding box. And then after a moment, you'll get an AI description. It can sometimes take some time to process the AI description.
Examining. Mesh size : x = 80.00, y = 80.00, z = 80.00. AI description : the model is a single, smooth sphere. Done. C:\users /Troy /example greater.
So that's exactly what we expected when we run 3DM info. This is a single smooth sphere. So now we're going to demonstrate editing the default model, and then we're going to run 3DM info and see that our changes have taken place. So in order to make this simple, we're going to create a little staircase kind of model. So it's going to have 3 steps, and the idea is that we can have 3 little blocks that have different heights but the same width and depth. So now I'll open the model and delete the sphere. Now I'm going to explain each model that I'm going to add, but I'm also going to read the whole thing afterwards, so you don't have to remember it. So first we're going to create a cube, and it's got a width of 10, a depth of 10, and a height of 10. Then we're going to create another cube to the right of it, so we're going to translate, and we're going to translate by x by 10, and then y and z by 0. And this cube is going to have a width of 10, a depth of 10, and a height of 20. Now likewise, we're going to create another cube, translate, we're going to move it to the right 20, 0, 0, and then the cube size is going to be 10, 10, 30. So I'm going to save this
/ setup
read the whole
/ your model code here. / set up parameters for smooth models by default $fs = 0.1 semi, $va = 1 semi, / your model code here cube left paren, left bracket 10, 10, 10 right bracket right paren, semi, translate left paren, left bracket 10, 0, 0 right bracket right paren, cube left paren, left bracket 10, 10, 20 right bracket right paren, semi. Translate left bracket 20, 0, 0 right paren, cube left bracket 10, 10, 30 right paren, semi.
So obviously, if you had this on your own machine, you could explore it line by
Folder
line.
view, pick command prompt
let's go
terminal
back
colon
into
/users /troy /example creator.
and we're going to do a 3DM build info. So 3DM doesn't automatically rebuild your model because sometimes building a model can take a while. So if we want info on the new version of the model, we have to also build it. You can do it in 2 separate commands, or you can put multiple commands together. So in this case, if we do 3DM build info, it will build it, which might take a second, and then it will give us an AI description.
Building, examining, mesh size colon, x equals 30.00, y equals 10.00, z equals 30.00, AI description colon. The model is a single piece shaped like 3 rectangular cubes stacked together forming an L shape. Each cube is progressively smaller, creating a stair step effect. The largest cube forms a base, with the medium sized cube on top of it and offset to the side. The smallest cube sits on top of a medium sized cube with the same offset. All the cube s have their faces aligned with each other. Done. C colon /users /troy /example creator.
So that description makes sense. It sounds like we achieved what we want to do. And just for the benefit of sighted users who might be watching this, we'll use Microsoft 3D Viewer just to view what it actually looks like. So now I'm back in the terminal, and let's say I want to slice this and print it. Well, I've already selected my printer when I did 3DM setup, although you can also change the printer when you run slice. So in order to slice it, since it's already built, I can just do 3DM slice. And you don't get a lot of noisy output from this process.
Slicing. Estimated print time colon, 23 minutes 5 seconds. Filament use colon, about 1.45 meters. Done. C colon /users /troy /example creator.
Now, some prints may require supports, for example, and in order to set supports, you can use the built-in support overlay. So the way you do that is 3DM slice -O, and then type supports. So you can have multiple -Os that add additional kind of sets of settings, and the overlays are described in the README. But if I run this, just to see, this model doesn't require any support, so it shouldn't actually take any more time.
Slicing. Estimated print time colon, 23 minutes 5 seconds. Filament use colon, about 1.45 meters. Done. C colon /users /troy /example creator.
So if you remember from the last one, that is exactly the same time and amount of filament. So sometimes you can kind of catch weird things going on just by trying to print with and without supports, or trying to slice with and without supports, and seeing how the print time changes. If we are using a printer with an SD card, we can simply copy the file, which is located in the build directory. So let me list the build directory. dir space /b, and then build.
Example -main.code, main.stl, C colon /users /troy /example creator.
So example-main.g code is what it's called. And so for the G code files, it'll have the name of the model and also the name of the project. The name of the project by default is taken from the project directory, although you can actually change it. So this means if you have a bunch of things on a SD card, they're not all called main.stl, you can kind of tell what project they came from. So we could just copy that to an SD card, but if you actually have Octoprint set up, you can run 3DM print and it will actually print it for you. It'll slice it, print it, upload it to Octoprint. I'm not going to do that right now because I don't have Octoprint configured here, but that can save you additional time versus opening the web interface and navigating in and uploading the file. So I also want to highlight one additional feature that 3DMake has, which is called tactile previews. Tactile previews are a kind of bridge between the audio descriptions that AI gives you, which are very fast to generate, but sometimes they're missing important details or even they get things wrong, and printing the model and feeling it yourself, because when you print the model, it can take a lot of time. The tactile previews that 3DMake creates for you today are called silhouettes. So they are basically very short prints that you print out on your 3D printer, and they're like a 2D object that you can feel on your build plate. Now, the advantage of these 2D prints is that they're extremely quick to print because there are only a few layers. So if I do a 3DM preview, and let's say I want it to just create the preview, slice it, and get all the information about it, I can do 3DM preview slice. Now, if I hit enter, it will create this silhouette preview, which is an STL file. We can see it in the build directory, and then it will slice it. And this file will contain tactile 2D representations of the object from 3 different angles. So kind of in the front right, you'll have an object representation from the front of the object forward. And then above that, you'll have a top-down representation of the object. And then on the left, you'll have a left to right kind of view silhouette representation of the object. So there's a good doc on the 3DMake documentation website that describes more about how these silhouettes can be read. Let's just run it and see what the print time is.
Preparing preview. Slicing. Estimated print time: 1 minute 23 seconds. Filament use: about 17.5 centimeters. Done. C: /users /Troy /example grader.
So you can see that that's only 1 minute and 23 seconds. And because this is a simple kind of model, you could actually detect, whether you like the stair sizes, whether the heights are right, whether the three cubes are connected to each other, just by doing this tactile preview in 2 minutes. And then if you had any issues, you could save yourself the need to do that bad print all the way to completion. So that's something that you can print by doing 3DM preview print or 3DM preview slice print. We're also just going to briefly take a look at the sliced model. So if we do a dir /b build,
example -main -resil.code, example -main.code, main-resil.stl, main.stl, C: /users /Troy /example grader.
So the -3sil, main-3sil.stl is the preview, and it's a specific kind of preview. It's the one that has 3 silhouettes together. You can use the -v option to select other views, like just a silhouette from the top or just a silhouette from the front. Those will be faster to print. And if you know that the problem is visible by feeling the silhouette from the front, then you can just print that one. Now, we can use 3DM info to describe the preview. And that's because you can use 3DM info to describe any STL file directly. So if you download an STL file, it doesn't need to be part of a project. You can use 3DM info to describe it. So I'm going to do 3DM info build / main-3sil.stl. And when I run that, it will AI describe that.
Examining. Mesh size: x = 50.00, y = 50.00, z = 0.60. AI description: the model consists of 3 separate parts. 2 of the parts are identical, thin rectangular solids. The third part is shaped like a staircase, or a set of 3 progressively larger rectangular solids stacked next to each other, each any offset from its neighbor. The smallest step of the staircase part is the same thickness as the 2 rectangular solid parts. Done. C: /users /Troy /example grader.
That was a little bit of a long description, but if you listen to it and think about what we tried to create with the staircase, it totally makes sense. So that's the AI description, and it kind of shows that the model is working correctly and that you could learn a lot about your staircase just by feeling this particular model. So I also wanted to describe a little bit about printer profiles and how you can edit and create custom profiles for your prints. So you may want to change things like the infill percentage, or you may want to change the print speed. And you can do that using something called overlays. So the way 3DMake settings work is that you have a default printer profile that you've selected, and that has a lot of settings for the printer, including things that you very likely don't want to change, like the bed size. And then you can create collections of setting overrides that have a name that are kind of bundled together, and these are called overlays. So for example, you may want to create an overlay to make your print stronger, that would have thicker walls for the print, that would have a higher infile density, a higher top and bottom thickness, and you could call that strong print. And that would allow you to, whenever you want to make your print stronger, instead of having to go in and edit your profile to change all of those settings, you could just use the strong print overlay. So let's actually do that. So we can do 3DM edit-overlay.
Which overlay?
So I'm going to call it strong-print. So you want this to all be one word without any spaces, but a dash is fine.
No overlay called strong-print. Create one. Left paren,
So
y or n right paren.
yes.
Limit this profile to a specific printer. Left paren, y or n right paren, :
So you can have overlays that are limited to a specific printer, or you can have overlays that work with all printers. If you have 2 overlays with the same name, it will use the one for your specific printer if it exists. I'm not going to limit it here.
Strong-print notepad. Text editor edit multi-line semi. This template lists the most common settings you may want to change, with example values.
So I'm just going to briefly read the start lines of this file, which contain a header, and kind of explain how it works. And then we'll go and change some of the settings and delete the other settings that we don't care about. So I'm going to tell NVDA to read this.
This template lists the most common settings you may want to change, with example values lines beginning with a semicolon or comment delete any settings you don't want your overlay to alter left paren. You will probably end up deleting most of the lines right paren. Layer line height = 0.2, nozzle line diameter = 0.4, temperature = 205, bed line temperature.
So I stopped that there, and we actually don't really want to change the layer height or the
Semi-temperature.
nozzle diameter.
Nozzle layer, folder view.
So I'm going to delete those
Caret
lines.
semi.
I'm going to delete the temperature
folder view.
lines.
Semi-temperature select caret return semi.
We have speed lines.
Semi-speed.
I'm going to delete
Retract
them.
semi-infill. Semi-infill selected. Semi-infill caret return semi.
Now we're in an infill section.
Fill line density = 15%.
Now I can change that,
1%.
and let's say make it 30%. Or 30% is actually more than you would probably ever want to do to make your part strong, but this is an extra strong part, let's say.
Semi-pattern can be grid, gyroid, stars, rectilinear, triangles, etc. Fill line pattern = grid.
So this is the fill line pattern called grid, and we'll just leave
fill line pattern = grid.
Now there's a support
Support line.
material section.
Firefox.
I'm going to
Semi-support line.
delete
Character
all of
return.
those.
Fill line pattern. Firefox. Unselect. Character.
And then
Semi.
we have a section called model strength.
Semi-model strength. Semi-perimeters is a wall thickness in lines. Perimeters equal E. R. S.
So by default,
Space.
this
2.
is 2.
Character return.
Let's
2.
change it to 10.
Bottom line solid line layers equals to E.
Let's
Character T.
change
Character return.
that to 4.
Top line solid line layers equals to 2.
Let's change that to 4.
Semi-build plate
And then
adhesion.
we're going to delete.
Search highlights. Command horizontal 0 used to change line feed.
So I'm going to save it, and
Semi-infill.
I'm going to
Fill line
read
density equals
all the
30%.
settings that we changed.
Semi-infill fill line density equals 30%. Semi-pattern can be grid, gyroid, stars, rectilinear, triangles, etc. Fill line pattern equals grid. Semi-model strength. Semi-perimeters is a wall thickness. In lines perimeters equals 10. Bottom line solid line layers equals 4. Top line solid line layers equals 4.
So now we're going to slice the model using the overlay that we just created. And the old sliced print of this staircase took 23 minutes. So we expect that now we're going to be having a stronger model, we're going to be extruding more filament, that it probably will take longer. So that's one way we can check it. And the overlay is called strong print. So what we're going to do is 3DM, slice, and then we're going to select the overlay with -O, and then strong -print. By the way, you can actually set the default overlays for a particular 3DMake project in your 3dmake.toml file. So that allows you to not have to type it every time if a certain project requires specific overlays. So now, if I hit enter on this line,
Slicing. Estimated print time : 34 minutes 45 seconds. Filament use : about 2.52 meters. Done. C : /users /Troy /example grader.
so it used more time and actually more filament as well, which is exactly what we'd expect. So that demonstrates a lot of the different things that you can do with a 3DMake project. And one other thing I wanted to highlight a little bit more is that you can run 3DMake on any STL file you downloaded or OpenSCAD files that you downloaded as well. So to do this, I'm going to go into my home directory, and
C : /users /Troy grader.
I have an Eiffel Tower model that I downloaded called eiffel.stl. And this model, first of all, I can describe it. When you run a description, the AI doesn't know what the file name is. So if it thinks it looks like the Eiffel Tower, that's all the AI's own judgment. So we can sort of check whether models look reasonable this way. So if we do 3DM info eiffel.stl,
Examining. Mesh size : x equals 18.37, y equals 18.37, z equals 38.67. AI description : the model is of the Eiffel Tower. It has 4 links that curve inwards and upwards, meeting at a square platform. FR, OM is platform. The tower continues to rise, tapering inwards as it goes. There are open lattice structures through T, the tower's body. At the very top, there is a small ring dash-shaped feature. Done. C : /users /Troy grader.
So this ring-shaped feature that it describes, it's actually a little Eiffel Tower keychain. I didn't mention that, but the model picked up on that. So now we could also slice this. So if we do 3DM slice eiffel.stl, it will slice it into a G-code file, and that G-code file will be put in the current directory.
Slicing. Estimated print time : 11 minutes 12 seconds. Filament use : about 25.1 centimeters. Result is Eiffel.code. Done. C : /users /Troy grader.
So NVDA likes to read this G-code as code, and it just sounds like code. But that's what that is, and that result is just to remind you that it created a new file when you did this. So you could print this in 11 minutes, and you could also create a preview of these input files if you wanted, and you could send them to Octoprint using 3DM print. So that's 3DMake. If you try it and you have any feedback on it, please let me know. My email is troy@blindmakers.net. I'd be happy to get suggestions to collaborate on 3DMake with you, or to fix any bugs that you encounter, or to add support for your printer if it's not already bundled with 3DMake.